Good morning, everyone. This is Ranger Jake here in Yellowstone National Park. I want to thank you for joining us in the next installment of our 150th anniversary virtual video series. Today, we're standing along the Gardner River, just north of Mammoth Hot Springs. You can see it's a beautiful morning, little haze in the sky from the nearby fires. But today, we're joined by Todd Koel because we're going to be talking about the past, present, and future of fish management in Yellowstone National Park. Todd has been working in Yellowstone since 2001, is that correct?
Yep.
And he's got a PhD in fish ecology, and he is the leader of the native fish conservation program in Yellowstone.
Yes, sir.
All right, I got all that stuff right. So with that, I'm going to let you take it away. I'm going to jump behind the camera, and thanks for joining us today.
Sounds good. Well, Yellowstone National Park sits along the Continental Divide here, and is the headwaters of Yellowstone River, Madison River, Gallatin River, and the Snake River. And these are really pristine aquatic environments within which our native fish of the Yellowstone National Park have been able to persist for thousands and thousands of years. When the park was first created in 1872, there were 12 native species to the park. And the most known of these native species are the cutthroat trout, whitefish, and Arctic grayling, which are our native sport fishes of Yellowstone. When the park was first created, though, about half of the waters of Yellowstone National Park were naturally fishless. And the reason they were naturally fishless is because of the natural barriers that exist, waterfalls, and things like that. So once glaciers receded, 10, 12,000 years ago, fishes, when they moved back into this area, couldn't access a lot of these waters at the headwaters here in Yellowstone National Park. So they naturally did not contain fish. When folks started settling this region, Euro-Americans that came from out east and started settling in the Yellowstone area and recognized these fishless waters, they took it upon themselves to stock fish from elsewhere and bring those fish to the park. And that started actually in 1889. The first stocking of non-native fish in the park were rainbow trout in the headwaters of the Gibbon River, including Grebe and Wolf Lakes, right at the core of Yellowstone National Park. But then for decades over time, fish from outside Yellowstone were moved into the park to colonize on purpose by the U.S. Fish Commission, colonize these historically fishless waters. And the point back then was to provide fish for visitors to the park and fish for folks that were living in the park, for consumption, and angling and sport fishing opportunities. At the time, it really wasn't recognized what the impact of those non-native fish species might be on the native fish communities and our natural ecosystems here. But later, by the 1930s or so, some of that recognition, came to light. What was happening was non-native fish such as brook trout, brown trout, rainbow trout began displacing our native cutthroat trout in areas, where they historically were. And so the stocking of non-natives from outside Yellowstone ended in the mid-1930s, but by that time, a lot of, sort of irreversible harm maybe had already been done. So in the middle of 1900s, 1950s, and so on, a lot of the stocking and moving of fish around Yellowstone by managers kind of came to an end. There was a large hatchery operation on Yellowstone Lake in Yellowstone National Park that persisted from the late 1800s, early 1900s, and ended in the mid-1950s. And during that period, managers harvested eggs from Yellowstone cutthroat trout from the Yellowstone Lake ecosystem and shipped them by rail all over the country and actually to places around the world. Unfortunately, a lot of that harvesting of cutthroat trout eggs from the lake and shipping them elsewhere didn't really result in viable populations elsewhere. These fish are specialists in their environment. And so when that was recognized, and also the impact of that harvest from Yellowstone Lake, the eggs from the cutthroat trout of Yellowstone Lake and so on, really, it was a detriment to the population there. And so the whole operation shut down by the mid-1950s.
So you mentioned some negative impacts from, introduction of the non-native species. Like, what sort of things were people noticing that, they figured, this might not be a great thing to do?
So impacts by the non-native fish included predation. So fish like brown trout and non-native lake trout, which were introduced to Yellowstone Park, were feeding upon the native species. Some of these fish, like our native Arctic grayling here, are very vulnerable to predation, and so they just didn't persist, in the presence of something like brown trout in the Madison River, for example. Same would be with brook trout, where brook trout were introduced on top of cutthroat trout populations in the park. The brook trout over time outcompeted the cutthroat trout, and in many areas the cutthroat trout were totally extirpated from the streams where the brook trout were introduced. There are many examples of that across Yellowstone, especially in the northern range here.
And so apart from just, trout being gone, does that have any effects beyond just, if trout are gone, what does that mean for the rest of the ecosystem?
Yeah. I think at the scale that we observe across the park, in stream systems or small lakes, there's probably not that, has been documented anyway in terms of effects on the ecology. For example, a rainbow trout in a river or stream maybe means the same to an osprey as a cutthroat trout would have been.
Yep.
It's more of the recognition of the loss of the native fish and the natural biodiversity when it comes to those kind of systems. And that's not to say that within the stream itself, at a much smaller scale, changes in the invertebrate communities and so on definitely have occurred due to, whether there's a brown trout in the stream or a grayling or a cutthroat trout, for sure. But at a more of a macro scale, that's not what people, are observing. The major impact on the ecology of the park by a non-native fish is the impacts of non-native lake trout, which became introduced to Yellowstone Lake at some point during the 1900s, and were first found in 1994 in Yellowstone Lake. In that case, lake trout are a heavily predatory species. Cutthroat trout in Yellowstone Lake are the sole trout of the entire lake and the entire ecosystem there. And the impacts of lake trout on the cutthroat trout definitely cascaded through many of the trophic levels in that Yellowstone Lake ecosystem, which includes not only the lake itself, but all the tributary streams that feed into Yellowstone Lake, and also the Yellowstone River upstream and downstream of Yellowstone Lake, all impacted by non-native lake trout within the lake itself.
And so one thing you noticed, it seemed like you chose your words very carefully when you said sometime in the 1900s they were introduced.
Yeah.
So how long does it take if a fish, say, let me rephrase. Did you word it that way because it's hard to tell how long it takes for a fish population to start expanding, or in Yellowstone Lake?
So there are multiple hypotheses about how lake trout may have got to Yellowstone Lake. Mm-hmm. When they were first found in 1994, the thought was they were maybe illegally introduced by, some anglers maybe that just wanted them in the lake for fishing opportunities. But there's also evidence to suggest that lake trout may have just swam to Yellowstone Lake over Two Ocean Pass south of the park, because they were originally introduced in Lewis and Shoshone lakes in the Yellowstone National Park in 1890. Within a decade, they invaded Jackson Lake south of Yellowstone, and there's a natural connection from the Upper Snake River system, Pacific Creek, which meets a natural Atlantic Creek in the Upper Yellowstone River on Two Ocean Pass. Lake trout elsewhere in the west have proven their ability to invade headwater streams, including in Glacier National Park, and take over headwater lakes, and there's really no reason to believe that they haven't just done the same thing here. So that's why, we don't have we have anecdotal evidence, I guess you'd say, and some data that suggests for sure that lake trout move up into Pacific Creek from Jackson Lake. We've proven that with environmental DNA analysis. But beyond that, it's just a hypothesis that we're working on. Whether it happened or not, or is continuing to happen, we're not sure.
Yeah. So regardless of how they got there, they're here.
Yeah.
And you said they're having a big impact on the cutthroat trout. So, I mean, what's the park doing, to try to help restore that kind of native balance?
Sure. Mm-hmm. Yeah, so you're exactly right. Regardless of how lake trout got into Yellowstone Lake, it doesn't matter. They're non-native. They're incredibly invasive, and their impact on the native cutthroat trout of the lake has been huge, and the ecosystem that sort of depends on the cutthroat trout as a keystone species and a food resource for many, avian and terrestrial predators such as ospreys, bald eagles, river otters, grizzly bears, and black bears, and so on. We documented over decades of time the loss of the cutthroat trout due to the lake trout, and then the shift in use of cutthroat trout by these species. One of the most significant, I think, along with grizzly bears and black bears not using the spawning stream very much to feed on cutthroat anymore, was the loss of ospreys around Yellowstone Lake. When I first came, a little over 20 years ago, we'd have between 40 and 60 osprey nests around Yellowstone Lake. Ospreys only eat fish. The cutthroat trout was their main, their diet. But by the year 2010, we were down to just 1 or 2 osprey nests per year around Yellowstone Lake, and that kind of continues today.
Well, and why don't osprey and the rest of the animals just eat lake trout instead of cutthroat trout?
So lake trout are not an ecological replacement for cutthroat trout because they dwell deep within Yellowstone Lake, and they don't use tributary streams to spawn. They spawn in the lake, typically deep within the lake. And so they're not accessible by these avian and terrestrial predators around the lake ecosystem. So basically what we have is an invasive non-native lake trout population that's consuming the native cutthroat trout in the lake and taking that energy away then from ospreys, eagles, bears, and so on. That energy that used to be available to those species now is tied up in the lake trout population within the lake. And so we're doing now, where we're at, is we're doing an aggressive removal program for lake trout, which actually started in 1995, and it continues even today. And we've removed over 4.2 million lake trout during this period. What we've done is driven the adult portion of the population of the lake trout down by over 80% in just the last 10 years with our incredibly large effort out there to net them and kill them. And the cutthroat trout population has rebounded, and now is another. It's regained its importance in the ecology of the ecosystem. The native cutthroat trout have. Yeah.
So you said where the lake trout are, they're deeper in the lake. I mean, when you say deep in the lake, how deep is Yellowstone Lake?
Yeah, Yellowstone Lake in some places can reach 400 feet, but that's not lake trout habitat. Lake trout habitat is typically out to about 160 or 180 feet of depth. And when the lake thermally stratifies during the summer for a very short period, actually, in Yellowstone Lake, which would be, basically at about, 36 feet, 40 feet down. The lake trout are typically then below that thermocline, and the cutthroat trout are more generally above it. And so we target the lake trout by our netting where they live in typically deeper habitats to avoid the bycatch of the cutthroat in the shallower habitats. That's how we conduct the netting.
Cool.
Yeah.
So in addition to netting, are you guys doing anything else? You're talking about bringing the adult population down, but does that mean that we're just going to have to net forever, or like what? Like, are there other things that we can do to try to get the population down?
So with the technologies that we have right now, lake trout will persist in the lake forever. We'll never be able to completely remove them, but we need and we are developing ways to be more efficient at suppressing the population. Gill netting will always be a core strategy, but maybe not. It'll maybe be more strategic and more targeted on certain times of the year and certain locations where they are, versus the all-out, broad scale netting that we implement now from mid-May to mid-October. But along with the gill netting, we are working on ways to suppress lake trout by killing the embryos on their spawning sites in the fall. And we've developed methods that basically depend on organic material. We started to use lake trout carcasses themselves from the netting program, where we put the carcasses on the spawning sites in the fall, and the organic decomposition of the carcasses removes the oxygen, dissolved oxygen from that area locally, and then kills the lake trout embryos on these spawning sites.
So two questions is, one, how did anybody figure out that worked? And then the other one is how'd you find out where they're spawning?
Okay.
In such a big lake, it seems like that's like needle in a haystack stuff.
There you go. Well, there's a great crew working on Yellowstone Lake that spends a lot of time out there, and obviously it's kind of a big part of our lives. And so we do spend a lot of times kicking around ideas between us, and this is one of them that came up. And it worked out great, but our problem with carcass material is that the lake trout spawn in mid to late September, and then we have to do the treatments after they spawn in October. And that's right when our netting operations are shutting down for the year because winter's moving in. And so the carcass material becomes hard to come by. We're running out of it. And also winter's moving in and we need to get shut down. So we have a very short period of time to treat these spawning areas. And we've developed, these pellets that we're using now, which are just basically wheat gluten and soy based, essentially like fish feed, which were created to sink fast. And we can treat these sites with these pellets and have the same outcome. We can kill all of the embryos using this material. But you're right in that there's a lot of spawning areas around Yellowstone Lake. We know of 14 of them that we've discovered by the gill netting operations itself, and by telemetry of the lake trout. So for a long time, we've been putting tags in lake trout, in adult lake trout, and they give out an acoustic signal in the water, and then we can listen for that sound in the water and track those lake trout through the summer and then in the fall, especially in the fall, to where they spawn. So we're using tagged lake trout to lead us to essentially the rest of the fish in the lake. They're friends, if you want to think about it that way. And then we're putting the herd on them in those areas where they're congregating by netting or other means. Yeah.
Did I hear the term Judas fish? Is that what that's called?
That is what it's called, Judas fish. Yeah.
Cool.
And it works.
Yeah. So that's what you're doing now. I mean, it's a big operation. How many boats do you have out on the lake in the summer, and how much net, all that? What's that look like by the numbers?
Yeah. Around 2012 is when we got our funding increased enough to a point, and this is due to a lot to private donations through what's now Yellowstone Forever, our fundraising partner for the park, to the tune of $1 million a year beginning in 2012.
Wow. With
that gift, and along with Park Service dollars, we were able to get the amount of effort to remove lake trout increased great enough so the population no longer, it was increasing. We've been driving it down ever since. So for a decade now, we've been putting that lake trout population into decline. Essentially, we have about 6 large specialized netting vessels. 4 of them are operated by contract netting crews, and the other 2 by our Park Service netting crews. And those combined netting crews are basically placing and then retrieving 6,000 miles of net each summer between between May and October.
6,000 miles.
Which is enough net, I think, to reach from Yellowstone to Italy.
That's crazy.
Yeah, it is crazy. On any given day, we'll have 40 to 50 miles of net in the water, killing lake trout. And again, that goes from ice off in the spring until mid-October. You know, at Yellowstone Lake, the crew sizes are between, you know, 40 to 50 people now. And so we've kind of maxed out the housing availability at lake for the crews. We've maxed out dock space on Bridge Bay. We've kind of, I guess I'm saying this because we've reached a point where we really can't increase effort anymore. So it's really a good thing that the effort we're putting out there now is driving the lake trout population into decline. But the challenge we're having is that although the adult segment of the population has collapsed, you know, by 80% that I mentioned, they are compensating for that removal. The population is compensating by producing a lot of young that we then need to make sure we net out of the lake before they become reproductive age adults, which is about 5 or 6 years old. And that's what we're doing. Yeah. Even though they're producing lots of young every year, most of those young are dead before they become reproductive adults.
Gotcha.
Yeah.
So with this huge effort, and you did mention that with our current technology, there's no way to ever kind of stop what we're doing.
Yeah.
So looking to the future, what does that look like? Is this what we're doing forever? Or is there a point in time when we can like scale back and keep like a, you know, a lessened version of what we're doing, or what's that look like?
I think that's our goal. You know, we work with partners in the universities and so on. We do statistical population modeling of the lake trout, and so we use those models to estimate what our effort needs to be each year, and then forecast into the future how much we could reduce and maintain where we are. And so we have those models. It does suggest we can reduce by a substantial amount. But again, these are models, and there's error in these models. Yeah. And so we would not want to reduce any kind of suppression too much, because if the lake trout are allowed to rebound over a few years of time, they would get great momentum that we would have to then deal with in the future. So there's a lot of uncertainty there in how far we can reduce suppression. But I think the main thing will be, once we see the adult population of the lake trout not be able to produce so many young each year, at that point we'll probably be in a more comfortable place to cut down the suppression effort to some extent, reduce the cost to some extent, bring in these other alternative methods to suppress the population, like the embryo suppression I talked about, and so on.
The other thing too, the video that we recorded before this one was with Ann Rodman. We were talking about climate change, mm-hmm. and one of the examples of, you know, how recreation can be affected in the park was last summer we had to temporarily close fishing in parts of the park because the water was too warm and it was kind of stressing out the fish.
Yeah.
So are there any other things similar, like, you know, to your research and your work and with the modeling and everything? Is climate change, are you guys anticipating any, you know, positive or negative impacts to native and or non-native species moving into the future?
I think Yellowstone Lake is considered a pretty, I wouldn't say totally stable or safe environment going forward in the face of climate change, but it's probably the best that it can be. We do have concerns in that the connectivity of the streams on drought years, it becomes an issue where tributaries to Yellowstone Lake become disconnected from the lake itself, so there's no surface water connection in drought years. So if cutthroat trout are produced in some of these streams in the spring and then emerge as fry in these streams later in the summer, if they don't have a surface water connection back to the lake before fall, you know, they might not persist. There's we're not sure about a lot of that, but in general, lake levels and stream runoff due to maybe reduced snowpack and things like that could affect cutthroat trout down there over the long term. But what we're seeing more so when it comes to hot, you know, dry and drought years, like you mentioned last year, is more on the stream ecosystems. And the lack of volume, which occurred last year, for example, on the Lamar River, the discharge, the volume of water flowing down the Lamar River in 2021 was lower than ever recorded in the history of that river. And so when that happens, there's not a lot of habitat for the fish. The stream temperatures rise really quickly, and then we end up having to implement some fishing closures to kind of keep those fish from being stressed during hot periods of the day.
Well, and then on the flip side, last year, too low of water. This year we have, historic floods. That's another question that we got a lot on social media. What's the wildlife doing? And it seems like most of the wildlife in Lamar Valley were able to just kind of move out of the way. But, that same question with the fish, like, have you guys been able to look into that, or do you have any kind of anecdotal?
Yeah. And it turns out we have a graduate student that's working on the Lamar River. He worked last year assessing the cutthroat population for us. And then he's also working this year after the flood. And he noted a change in the numbers of cutthroat in lower Slough Creek and lower Lamar, apparently due to the massive flood event that we had. These populations, though, in some of these streams in the park, for example, Soda Butte Creek, it's common where you'll get pretty large runoff events during the snowmelt in the spring. The population will be depressed for a year or two, but then rebound. It just appears like genetically they're sort of programmed to be able to do that. And I'm pretty confident the same will occur elsewhere in the park. I know that anglers across Yellowstone this summer have the comments that are coming to me as the lead fish person in the park are all positive. No one's reaching out to me and saying, "Hey, Todd, there's no fish left here in this stream." No one's done that. And in fact, it's been a lot of the opposite. And so I think the flood event may be a short-term impact on some areas, but overall not a big deal.
And during a flood or high water, do the fish just get washed downstream, or what?
I think a little of both.
Yeah.
Yeah. They're either be able to tuck in and hold tight or get washed downstream for who knows how long. Now, you asked about non-native effects of temperature and so on non-native fish. And there's no question that in some streams where especially brown trout occur, brown trout will have an advantage in warmer waters over our native fish for sure. And that's playing out in other parts of Montana, in the Intermountain West here, even down south in Teton Park and so on in Jackson Lake. Brown trout are increasing in abundance in a lot of these areas, and that will occur here too.
Gotcha.
Yeah.
So one of the things I like to do in this video series is, after we're kind of talking about all the work that we're doing, is ask like kind of an anecdotal question to the individuals that are doing it. So since you've been here for 21 years, is there like a particular project or moment in time or some like breakthrough that you've been a part of that you're most proud of as doing
Sure.
The fish conservation program?
It's pretty awesome now. 20 years into this, we had a native fish conservation plan that we produced in 2010, and that's been our guiding document here over the past, well, now I guess up to 12 years or so. But we've been able to remove non-natives from a lot of headwater stream systems and a lot of interior lakes and so on, and now have native fish in places where they haven't been for over a century in some cases, And so West Slope cutthroat trout, Arctic grayling, and Yellowstone cutthroat trout. And it's in a lot of these spots that we've restored these fish are accessible to the public, and for kids even to experience. And I just love seeing that. And probably the most significant for me of it all is the spawning run of the Yellowstone cutthroat trout in Yellowstone Lake, south of Yellowstone Lake, up the upper Yellowstone River into the thoroughfare backcountry and into this area that I described before called Two Ocean Pass and Atlantic Creek. We've restored that spawning run. The fish are huge, 20, 22, 24, 26 inches long, red like salmon. They run up there, which is 30 plus miles into the backcountry. And I've been able to experience that spawning run myself. and see all the backcountry camps that are now in that remote ecosystem, which is actually outside of Yellowstone in the Bridger-Teton wilderness area. But that pulse of cutthroat trout that comes out of Yellowstone Lake back into that remote backcountry area, again, there's no other fish back there. And so that whole ecosystem depends on that pulse of spawning fish into the backcountry, not only then for the ecology of that whole huge area, but then for anglers like myself and the others that sort of converge on that area in late June and into July during that peak of the period when the cutthroat go there to spawn. And for me, that's the most awesome thing I could ever imagine, kind of having a part of restoring that to this great, ecosystem that we live in.
That is awesome.
Yeah, thanks.
Well, with that, I'm going to jump back on camera. I want to thank everyone for watching the video today. Hopefully you learned a little bit. I want to thank Todd for joining us today. And thank you for your support of Yellowstone National Park, and we'll see you on the next video.